Prefix Sum, a super useful LeetCode pattern that can optimize the time complexity of many array-related problems from order of n square to order of n. If you go on LeetCode, there are currently 173 problems tagged with this pattern, which shows just how important it is. In this video, you will learn what a prefix sum is, how to implement it in code, when to use this pattern, and I will walk you through multiple LeetCode problems to help you understand it better. I will also share more LeetCode problems you can practice after watching this video to help you master this pattern. So let's get into it. What is a prefix sum? In simple terms, a prefix sum for an array is the cumulative sum of elements from the start of the array to a given index. Here is how to create a prefix sum array in code. Initialize a prefix sum array of the same size as the input array. Assign the first element of the prefix sum array to be the same as the first element of the input array. Iterate over the input array, updating each element of the prefix sum array using the formula prefix sum at I is equal to prefix sum at I minus 1 plus the array value at I. One thing to remember is that sometimes you don't even need a new array. You can modify the original array itself and use it as a prefix sum array if memory is a constraint. Here are a few common scenarios where this pattern can be used. Range sum queries, where you need to compute the sum of elements between two indices frequently. And subarray sum problems, where you need to find or count the number of subarrays that add up to a specific value. Now let's apply what we have learned to solve some LeetCode problems. Just a quick note, if at any point you feel like pausing the video and trying the problem yourself, I encourage you to do that. First problem is LeetCode 303 range sum query immutable. Given an integer array, answer queries that ask for the sum of elements between two indices. A brute force approach to solve this would iterate from the start to end index for each query. However, this can take O of n time per query in the worst case, where n is the number of elements in the array. We can optimize this to O of 1 time per query using the prefix sum approach. Here is how it works. In the constructor, transform the input array into a prefix sum array to avoid using extra space. To calculate the sum between two indices left and right, we can simply use the formula prefix sum at right minus prefix sum at left minus 1. There is an edge case when left is 0. We can handle it separately by returning the prefix sum value at right. Next problem, LeetCode 560 subarray sum equals k. Given an array of integers nums and an integer k, return the number of subarrays whose sum equals k. For example, if our array is and k is 5, there are two subarrays that sum to 5. The brute force approach iterates over all possible subarrays using nested for loops and counting subarrays whose sum equals to k. However, this approach has a time complexity of order of n square. We can optimize this to order of n time using the prefix sum approach. The idea is that if the difference between two prefix sums equals k, we have found a subarray that sums to k. If prefix sum at right minus prefix sum at left minus 1 is equal to k, the subarray between indices left and right has a sum of k. For each right index, there could be multiple left indices if the array contains negative numbers. We can rearrange this equation to prefix sum at right minus k is equal to prefix sum at left minus 1. Thus, the problem reduces to counting how many times we have seen the difference prefix sum at right minus k in the previous prefix sums. To store the frequency of each prefix sum, we will use a hash map. Here is how it looks like in code. Initialize a prefix sum variable to 0 to hold the cumulative sum of elements as we iterate through the array. Initialize a count variable to 0 to store the number of subarrays whose sum equals k. Create a hash map called prefix sum frequency to store the frequency of each prefix sum we encounter. Initialize the hash map with a value of 1 at index 0 to account for cases where the subarray with sum k starts at index 0. Iterate through the array. Add each element to the current prefix sum. Check if the difference prefix sum minus k exists in the hash map. If it does, it means there are valid subarrays with sum equals to k. Increase the count by the frequency of prefix sum minus k. Update the hash map with the current prefix sum for future iterations. Finally, return the count of subarrays. The time complexity of this approach is order of n, since we only iterate through the array once. The space complexity is also of n, since we use a hash map to store the prefix sums, which in the worst case may store n distinct prefix sum values. Now that you know how to use the prefix sum pattern, here are some more LeetCode problems you can practice to master this pattern. I have added links to these problems in a blog that you can find in the description. I hope you found this video helpful. To stay up to date on DSA and system design, consider joining my free newsletter at blog.algomaster.io. If you want to check out the full LeetCode patterns playlist, click here. I will be making more such videos on important patterns, so make sure to subscribe if you don't want to miss them. Thanks for watching, and I will see you in the next one.